Okay, so like I said, today focusing on what happens if it's bigger than a full circle and what happens if it's a reciprocal. Bigger than a full circle, again, we already got that intro to in our assignment. Hopefully you were able to figure it out and just kind of apply what we know about how to draw our angles. All students take calc, reference angles, and then finding our answer is no different than if it was under a full circle. So let's start with one of those. Cosine of 9 pi over 4. So again, at this time, you're going to focus on whatever your method is. Regardless of my method, the first thing I'm going to do is either visualize in my head or draw on paper what that angle looks like so that I can answer what quadrant it would fall into, and so that I can then identify if my answer would be positive or negative. So let's draw 9 pi over 4. Bigger than a full circle, right? A full circle in terms of fours would be 8 pi over 4. And I'm supposed to go 9 pi over 4, which means I am just past a full circle. So two things I learned from that. One of those is what quadrant my angle falls into, which is quadrant 1. Tells me my answer is positive because all functions are positive in quadrant 1. Also, my reference angle would go back to that 0, or because it's in radians, also very easy for me to identify, is that my reference angle would be pi over 4. Now, once those two things are addressed, I don't really care that it is 9 pi over 4. I have everything I need. My answer is positive. My reference angle is pi over 4. Proceed like normal. Okay, so now we've eliminated the fact that it's bigger than a full circle. We already know how to do this problem. So now I go to my method. You try out your method while I draw all of these up here. So I would either be picturing my special right triangle, I would be picturing the pi over 4 angle in quadrant 1, or I'd be going to my hand trick. Pi over 4 is my middle finger, cosine, comma, sine, just like our ordered pairs. 2 cosine fingers, our answer should be a positive because we are in quadrant 1, square root of 2 over 2. Questions on what happens if it's bigger than a full circle? In radians, also very easy. Again, this is one of the other reasons we love radians. Very easy to figure out my reference angle. A little bit trickier if it is in degrees. So we'll talk about that, but it's no different. We've practiced the reference angles before. Okay, go ahead and try this one on your own. Sine of negative 8 pi over 3. Probably our most challenging part of this is drawing 8 pi over 3. Remember, fall back when we were talking radians into considering half a circle 3 over 3, a full circle 6 over 3. How many thirds are we going here? How much bigger than a full circle, right? You are supposed to head in the negative direction. Let's see if we ended up in the correct quadrant as we did this. So negative 8 over 3. So if I think in thirds here, there's negative 6 pi over 3. I'm too short because I'm supposed to get up to 8. So there'd be another 7 pi over 3, 8 pi over 3, 9 pi over 3 would have put me on that next axis. You should have fallen into quadrant 3. Do I need to go through that again? So as I consider my all students take calc, in quadrant 3, a sign question should be negative. My answer to this is negative something. My reference angle, again, reason we love radians is pi over 3. I don't really have to think about anything other than that. So go to your method, visualize your pi over 3 reference angle in a special right triangle. Or visualize pi over 3 in your quadrant 1. Or my hand trick people, pi over 3 would be your pointer finger. Pi over 6, pi over 4, pi over 3. Cosine comma sine is my bottom fingers. I have 3 bottom fingers, square root of 3 over 2 negative, because we are in quadrant 3 doing a sine problem. Questions? Or opposite over hypotenuse, or sine is your second value in each of those ordered pairs. Pick your method. All right. What if it's degrees and bigger than a full circle? Okay, no different. Draw me 405 degrees. Okay, I do not want you to be caught off guard, but come the gateway / the DCA over trig values that you will take in accompanying with your test next week over this chapter, it is all no calculator. We have just a couple questions where I would have preferred to have a calculator to be able to help me. But ultimately, if I need to come off to the side and say, okay, well, how much bigger than a full circle is this? I really can do old school math here and just subtract, right? To figure out how much bigger than a full circle this is. So let's see, 5 minus 0 is 5. Let's see, borrow 1, right? 10 minus 6 is 4. So it's 45 degrees bigger, right? If I have to go off to the side and do that, I can, to help me figure out how much more. So it's a full circle and another 45 degrees to give me 405 degrees. Full circle and another 45. And it kind of helps me figure out my reference angle going back here, right? That distance is 45 degrees. Also drawing this, I now know that we are in quadrant 1 and all answers are positive in quadrant 1. So my answer to tangent of 45 degrees, 405 degrees, is positive. Go to my model for 45 degrees, go to my 45 degree ordered pair in my first quadrant, and do, well, here, opposite over adjacent. Here, I would do sine value over cosine value, which is our y number over our x number. Or in my hand trick, remember tangent, I do my reference angle, which is my middle finger for 45 degrees. And tangent, I need to look at the back of my hand. And I do the square root of my fingers over the square root of my fingers, which in this case would be the square root of 2 over the square root of 2. Just don't jump ahead, because a lot of people would jump into rationalizing that. But if it's the same thing in the top and the bottom of my fraction, it is 1, right? And if I rationalize that, ultimately it would simplify down to that. You would end up with like 2 over 2, which is fine, but it is 1. Regardless of the method I take, I would end up with the same thing in the top and the bottom of that fraction, which would ultimately all simplify down to 1. And the tangent of 45 degrees is always 1. Okay, that's never going to change. Questions? Okay. So what about our reciprocals? Secant, cosecant, and cotangent. Nothing changes about our process. We're going to draw the angle. We're going to decide if our answer is positive or negative. But ultimately, what I would want to be thinking in the back of my mind is doing this problem as the reciprocal version first and turning my answer upside down. Now, it's going to be a little different via my method. Okay, so in the back of my mind, I first of all want to be thinking about what is the reciprocal of cosecant? What's the reciprocal of cosecant? Or cosecant's the reciprocal of which? Sine, cosine, or tangent? Sine, right? That's important. You have to know which one is the reciprocal of, or I can't find it, first of all. It is the reciprocal of sine. So for 2 out of my 3 methods, I'm actually just going to do the question sine of 300 degrees first. But let's start by just drawing that picture for ourselves. So 300 degrees would put me into quadrant 4. Now, in my all students take calc, what is the only thing positive in quadrant 4? Cosine. But what we don't talk about in all students take calc is that it also includes the reciprocals. So this would be also cosecant. This would be also cotangent. And this would be also secant, right? So the fact that we're thinking sine or that it's not cosine or secant tells me that our answer to this is some negative number. Questions so far? So again, think through its reciprocal. Sine is negative in quadrant 4, which means its reciprocal is negative in quadrant 4. Okay, if I am a special right triangle, oh, what's our reference angle? 60 degrees. Okay, so if I am a special right triangles person, I would right now be visualizing that 60 degrees right here, its model, and the fact that sine in SOHCAHTOA is opposite over hypotenuse, my answer to cosecant is going to be my hypotenuse over my opposite sine, right? And I can set that ratio up. If I am either of the other 2 methods, my memorized quadrant 1 people, here's my 60 degrees, okay? Or my hand trick people, what I'm going to do is basically answer this question first. What is the sine of 300 degrees? Okay. So first of all, the sine of 300 degrees is square root of 3 over 2, 60 degree reference angle, cosine fingers, comma, sine fingers. I have 3 sine fingers, square root of 3 over 2. And when I answer this question, to then answer this question here, I must reciprocal it. That's all I have to do is turn it upside down. Now you're going to recognize where this will simplify to eventually, because you'll do the, I mean, there's a lot of them that are square root of 3 over 2 that we turn upside down. It does require rationalizing. Hopefully you'll be able to jump to the simplified version here quickly. And it simplifies to 2 square root of 3 over 3. Negative, because we were in quadrant 4. What I just did right here is the same thing I would do if I was a quadrant 1 person, is I would take my sine answer, there's my sine answer, I would turn it upside down and I would simplify it. Questions on your different methods? Your answer, negative 2 square root of 3 over 3. Okay, so that's what I said. If you got good at what we did on Friday, this follows along pretty easy, because all you have to do is answer the reciprocal and turn your fraction upside down. The 2 things people forget to do: finish the problem. They'll answer the sine of 300 and stop. Okay, they'll forget that they were like just starting it and they need to turn it over, or getting the sign wrong, which is always going to be one of our issues. Okay, so let's try another one. Secant of 5 pi over 4. So some of the things we need to remember for ourselves is, if it is a secant of 5 pi over 4, secant is the reciprocal of which trig function? Cosine, right? So in the back of my head, I am considering this also a cosine of 5 pi over 4 to help me decide if my answer is positive or negative, for some of us to help us work through the problem itself. But my first part does not change. 4 over 4 would be half a circle, so 5 over 4 would go just past that. I am in quadrant 3. Is my answer to this problem going to be positive or negative? Negative, right? Secant is the reciprocal of cosine. Both of those would be negative in quadrant 4. Again, now I'm going to consult my model. I'm going to consult my first quadrant, or I'm going to go to my hand trick. And ultimately, for most of us, think through the question, what is the cosine of 5 pi over 4? Okay, so hand trick people, here you go. My reference angle, pi over 4. cosine comma sine. My cosine is my top fingers. To cosine of 5 pi over 4, I should have come up with an answer of square root of 2 over 2. Turn that upside down and simplify. And again, we are going to see the same problems showing up over and over. Okay, square root of 2 times square root of 2 is 2, and you'll see the same thing happen every time. Is your 2's out front will simplify. This actually came from reciprocaling 1 over the square root of 2. Your answer is just a negative square root of 2. So when we turn square root of 2 over 2 upside down, it will always simplify down to just square root of 2. And as soon as you start recognizing that, again, you don't have to show that work. Just jump to the answer. Questions? Okay. All right. Cotangent of 5 pi over 3. Again, I know this is, I feel bad I can talk about these in a whole bunch of different ways, but tune in to me when I get to your method, okay? So first of all, cotangent being the reciprocal of tangent. The first part applies to everybody, 5 pi over 3. 5 pi over 3 should have been just short of a full circle, 6 pi over 3. Your answer should, or your angle should have fallen into quadrant 4. If we consider our all students take calc, cosine, secant, are the only things are positive in quadrant 4, which means our answer ultimately will be a negative number. Okay, let's talk my special right triangles people first. Our reference angle is pi over 3. So if I consult my pi over 3 model, pi over 3 is the same thing as 60 degrees. Now, tangent is opposite over adjacent, if I'm thinking triangle, SOHCAHTOA, which means cotangent is my adjacent over opposite, adjacent over opposite. So this would have been 1/2 divided by the square root of 3 over 2. Simplify from there. Okay. Similarly, if I am a memorized quadrant 1 person, my reference angle of pi over 3 would be here. That we have to remember that tangent is sine over cosine, which is our second number over our first, which means cotangent is a reciprocal of that. Your first answer over the second number in each of those. Okay, well, that would be 1/2 divided by the square root of 3 over 2. For both of these, we're at the same point. Let's talk the algebra to finish that. It would be 1/2 times the reciprocal. My 2's would cancel. I would rationalize and get square root of 3 over 3. My hand trick people, kind of 2 different ways we can talk about this, but for my hand trick, remember that I'm going to look at the back of my hand. My reference angle is pi over 3, which is your pointer finger. For tangent, I would turn it over and I would get the square root of 3 over the square root of 1. And for cotangent, I'm going to turn that upside down before I do any work here. So my answer to cotangent would have been the square root of 1 over the square root of 3, which I would have rationalized to get the same thing I get when I rationalize down here. Ultimately, the square root of 3 over 3. Now, hand trick people, I do want to point out one thing. When you did this, remember that we turned our hand over because this is our sine fingers and cosine comma sine, and tangent is sine over cosine, right? Just to point out, because I get asked this every time, well, since cotangent is supposed to be cosine over sine, you could just look at this side of your hand and get cosine over sine. Square root of fingers over square root of fingers. That is reciprocaling it without having to write it down. So there's your cosine, or cotangent, sorry. There's your cotangent. Square root of fingers over square root of fingers. You can just reciprocal it on your hand, okay? And yes, it works like that every time. Questions? All right. Cosecant of negative 210 degrees. What quadrant is negative 210 degrees in? 2. Which means our answer is positive, right? Cosecant is a reciprocal of sine. Sine is positive in quadrant 2, which means cosecant is positive in quadrant 2. What's our reference angle? 30 degrees. Very good. Okay. Consult your method. Most of us are going to start with the thought process of what is our answer to the sine of negative 210 degrees. Positive reference angle of 30 degrees. Look at your models, or here's my hand trick, people. 30 degrees is here, right? Small to big, 30, 45, 60, 30 degrees. Sine is your bottom fingers. So it'd be the square root of 1 over 2. Turn it upside down. So regardless of my method, I should be able to get to the fact that sine of 30 degrees or sine of negative 210 is 1/2. When I turn 1/2 upside down, I get 2 over 1, which simplifies down to just 2. Questions? Okay. You do have to rationalize. I do not accept answers that are not rationalized, but if you were to leave something like 2 over 1 as an answer, that's fine. Ultimately, I hope we recognize that 2 over 1 is just 2, but it's not wrong. Okay. Questions for me? All right, let's look at the ones that fall on an axis. We have not talked axis reciprocals yet. Regardless of my method, I would probably start by also all of my assignments, all of my quizzes and tests, drawing this picture for myself. You don't have to, but I don't want to like redraw it every time either. And it's got everything I need on it. Okay. In this, what I need to remember is in all of those ordered pairs, it goes my cosine answer, comma, my sine answer. And that tangent is always going to be that sine answer over my cosine answer, which is your y over your x. But what if I'm supposed to do a reciprocal for one of these? Okay, so let's start with our first example, cosecant of pi over 2. I just start the same I would have if it had said sine of pi over 2. We figure out which axis pi over 2 is referring to, right? So remember what that means for all of this. So 0, pi over 2, pi, and 3 pi over 2, and 2 pi. Or in degrees, 0, 90, 180. We've seen this a lot of times now, right? 270, 360. So we're looking at this point up here. So sometimes you might have this whole thing drawn, or you can just say, okay, it would end up here. What's that ordered pair? How do I get to that point? I go right or left, 0, up 1. And then what I'm going to do is identify for myself the reciprocal of this. The reciprocal of this is sine. Well, sine is your second value. The problem is that these don't look like fractions. So for all of these that fall on an axis, you have to make it look like a fraction. And I can always make a number look like a fraction by putting it over 1. So what I do is I make this look like a fraction by putting it over 1, and I turn that upside down. Well, 1 over 1 turned upside down is still 1, right? Great. What about the secant at pi over 2? This is where we have to slow down a little bit and where we're going to add a little info to this. Secant is the reciprocal of cosine at that same angle, right? Cosine is 0. If I make 0 look like a fraction, I'd put it over 1. But what happens when we turn that upside down? Undefined, right? Because this ends up being 1 over 0, which you are not allowed to leave that. You have to simplify that, and that simplifies to undefined. And cotangent being the reciprocal of tangent. So our tangent would be our sine value over our cosine value, which would have been 1 over 0, which makes cosine, cotangent our cosine over sine, 0 over 1. Turn that tangent upside down, and 0 over 1 simplifies to 0. Very important that this was what I was going to add to this page, is 1 over 0 and 0 over 1 and what that simplifies to. Okay, people make silly mistakes on that. Slow down. 0 in the top, 0. 0 in the bottom, undefined. Question. Okay, there's your reciprocals on an axis. So you just have to figure out which axis. Remember that it goes cosine comma sine, and tangent is sine over cosine. Simplify correctly. You try one on your own. 3 on your own. Okay, once I figure out which axis the angle drops me on, negative 180 degrees would put me here. I identify for myself the ordered pair, and it goes cosine comma sine, so negative 1 comma 0. And then I do my reciprocals. Cosecant is the reciprocal of sine. Sine is 0. When I reciprocal 0, we get 1 over 0. Ultimately, then our answer was undefined. Secant is the reciprocal of cosine. Cosine is our first value in there. So I would take negative 1 over 1. Turn that upside down, and that is still negative 1. 1 over negative 1 is negative 1. Cotangent would be my cosine over my sine. Turning tangent upside down, my cosine is negative 1, sine is 0. And negative 1 over 0 simplifies down to undefined. On an axis, you should not get any other answers besides that. 1, negative 1, 0, or undefined. That's your only options. Okay. Question. Okay. We will practice again tomorrow. And then we will take our first gateway on Friday.